In this lesson, we're going to talk about how to price a bond. Now, a bond is a way that a corporation or a government can break up a large amount of borrowing into smaller pieces. So let's talk a little bit about what a bond looks like. So the example that we'll use is a 3-year $1,000 Australorp bond pays interest at a semi-annual rate of 6%. So when we talk about a bond, what are we really talking about? Well, a bond is a contract, and on that contract it'll have the name of the issuing corporation. In this case it's Australorp Corporation. It'll have the face value, and that's what the corporation promises to pay back. Bonds are usually denominated in minimum amounts of $1,000. So if you ever have a problem and it asks you to price a bond but doesn't give you a face value, assume that it's $1,000. The other thing that the bond has on it is it's got an interest rate. That interest rate is called a coupon rate, and that's because we use that rate to figure out what the coupon payments are. Down on the bottom of the bond you see 6 boxes. It's a 3-year bond and it pays coupons semi-annually, so there's going to be 6 coupon payments. In the old days there were actually detachable coupons on the bottom of the bonds, and that's where these come from. To figure out the amount of the payment, or the amount that you would get each coupon payment date, you take your 6%, divide it by 2 because it's semi-annual, and then multiply that by the face value. So 6% divided by 2 is 3%, times 1,000 gives us $30 per coupon payment. So at the bottom of your bond you'd have these coupons with $30 printed on them. On the due date, which was every 6 months, you'd cut out your coupon, take it to the bank, and deposit it. So the bond itself looks like that. It has payments of $30 every 6 months, and there's 6 of them because it's going on for 3 years. And it's got this face value of $1,000, which means the issuing corporation, Australorp Corporation, promises to pay back $1,000 at the end of the 3 years as well. So when we talk about pricing a bond, the price of the bond is what investors are willing to pay for that bond, and they oftentimes use a different interest rate than the coupon rate on the bond. And this happens because the interest rate changes all the time. You listen to the news and you see that the Bank of Canada moves the interest rate. Well, that will affect the price of the bond. So let's look at an example. It's the same bond. It's a 3-year 6% coupon bond with semi-annual coupon payments, with the next coupon due in 6 months, and it's priced to yield. So the one that we'll start off with is 5% compounded semi-annually. So we'll do this on the calculator, and remember, on the calculator we need to set up our keys. So the fact that the first payment is due in 6 months, well, that's really telling us that the payments are happening at the end of the period, so we're going to turn off the begin function. It's a semi-annual interest rate, and our yield is semi-annual as well. So our payments are semi-annual. We've got coupon payments every 6 months, and the yield was quoted in a semi-annual amount, so our CY is going to be 2. N, when we're talking about an annuity, and this is partially an annuity, will be the number of payments. We've got 6 coupon payments. The payments themselves are $30, and the face value, or future value if you'd rather, is $1,000, and that's what the corporation promises to pay us back. Now, in a lot of annuities we don't worry too much about the sign, but in this case the sign is really, really important. And the reason for that is, if you're the investor, you get the $30 payments for interest, and you also get the $1,000 face values. They're both amounts of money coming to you, so they have to have the same sign. We will set them up with a positive sign. The last thing we need to know is what interest rate investors are going to use when they price these bonds, and in this case it's 5%. So what we're going to do is we're going to enter this stuff into our calculator, and we're going to compute the present value. So the first thing I'm going to do on my calculator is make sure the begin is off, and it is off because I don't see it there in the top right. The next thing I'm going to do is I'm going to set my PY and CY to 2. So I go second IY, and then I go 2, enter. And remember, if they're the same, you don't need to scroll down. When you set one, it will automatically set the other. So I'm just going to turn my calculator on and off again. 6 payments, so I go 6N. My yield was 5, so I'm going to go 5 for my IY. So remember, when you're doing a calculation, because I've set my PY and CY both to 2, I can just enter the nominal rate into my calculator. And we don't enter it in as 0.05, we enter it in as 5 for 5%, but you knew that. Our payment is 30, so I'm going to go 30 and then hit payment, and my future value is 1,000. So I put in 1,000 as my face value. And my last step then is to compute the present value. So I wind up with $1,027.54. So that means that investors are willing to pay $1,027.54 for every $1,000 or every face value of $1,000 on the bond. Another way to look at this is this bond is more attractive than when it was issued, because when bonds are issued, they're usually issued to be priced around $1,000. What this means is that the yield has gone down on this bond, so investors are willing to pay more for cash flows of $30 every 6 months and a future value of $1,000 in 3 years. One way to kind of think about this is when investors are pricing a bond, what they're saying is, how much would I need to invest to achieve a yield of 5%? So if the bond was priced to yield 6% and you only need 5%, well, that means the price of the bond is going to go up. The second parts of this and third part of this, all we're doing is we're changing the yield. So the nice thing is that the interest rate on the coupon, the PY, the CY, the coupon payments, and the future value, they're all going to stay the same. So if we look at Part B says price the bond if it yields 6%. So everything's the same. What we're going to do is we're going to enter 6% as our IY, our yield, and compute our present value. And if you think about it, we should already know what's going to happen. I haven't cleared my calculator, so I don't need to do anything else. But if the bond was set up to pay 6% and investors demand 6%, then the price of the bond is probably going to be the face value. And there it is. So all I did was change my IY to 6 and calculate the face value. Now for this next example, the yield has risen to 7%. Same bond, so begin, PY, CY, N, payment, and future value are all the same. All we're going to do is enter 7 in for our IY and compute a new present value. So now if we think about this, investors need to make 7%, so that means that they need to invest less money to get 7% because the return's higher. That means that the price of our bond is probably going to be less than $1,000. But let's check it out. So we're going to compute our present value, which is our price, and we wind up with $973.36. So we were right. The value of the bond does decline. Another term that you might hear when you're working through your problems is something called a strip bond. And if you think back to the original picture that we had of a bond, a strip bond is just a bond where the coupons have been torn away and all you're left with is the promise to pay $1,000 on the maturity date. So if we think about what that means, what it means is that it's the same bond except now we don't have any payments. So let's price this to yield 7%. And basically it's just a compound interest problem now. All we're doing is pricing the bond as a future value of $1,000 brought back to today, which is 3 years earlier than the maturity date. So what I did was I had the same information in my calculator already, so I didn't have to re-enter it in. I'm just going to zero out my payment and compute the present value again. And the present value drops to $813.50 because we're not getting those coupon payments every 6 months. And a lot of people like to use strip bonds when they want to save a certain amount. Then they don't have to worry about getting these coupon payments every 6 months and reinvesting them.